Scientists gather a lot of information, and just raw information can be very overwhelming, and so we classify things and we categorize things, and that's how we make sense out of the world. And we do that in our everyday lives without even thinking of it. We classify animals into groups, and you look at a cat and you recognize it as a cat, even though the one cat might be black and have short hair, and the next cat might be gray and have long fluffy hair. But you still recognize that that's a cat and not a dog. And then the variety in dogs is even greater. And yet somehow we can look at them and we pick out these common characteristics and we say, that's a dog, this is a cat. It's funny to watch, as children grow up, as they start to learn to distinguish. Which one was it? It was number 3. He was maybe 2 years old, and we were at Zion National Park, and he saw a fawn, just, not very far away. And he wasn't talking much. I don't think he was even 2 yet, not quite. And he pointed at it, and he says, "Ooh, ooh," which, woof, woof. It's a dog. Well, close, it's brown, it's got 4 legs. It bears a resemblance to a dog, but we recognize that's not a dog. And then as we gain experience, as a child gains experience with different animals, they begin to recognize these categories that we've put them in. So scientists use categories like that to distinguish between different types of matter as well. And at first, when you learn about them, it's a little confusing, because really, what is the difference between like a greyhound and a deer? The differences are pretty subtle. So bear with me on this and try to get familiar with these words that we're going to use. So we divide matter into 3 different physical states: solid, liquid, and gas. And water is a great thing because we're actually familiar with it in all 3 of its states. We have different names for it. When water is in the solid form, we call it ice. And liquid water we call water, and in the gas state we call it vapor or humidity or steam, right? That's just water in the gas state. The 3 states of matter are going to be different when we look at how the particles are arranged and what the particles are doing. In solid water, the water molecules are the same as in liquid water or water in the gas state, but how they're relating to each other is different. So the solid state is a little bit like you students in the classroom right now. You're all sitting in your stools at your benches, and you're not moving relative to each other, are you? When we have lab and we all get up and are walking around, that's like the liquid state of students. Okay? Bet you didn't know that students had 3 states too. So right now you're in the solid state. When we do lab, we're in the liquid state. We're still in a close, confined area. We're still near each other, but we're milling about. The gas state for students is when it's finally noon and class is over and we open the door and people go off in all kinds of directions, right? And then you're far, far away from each other. You don't even know what the other students are doing. And that's the gas state. So there's very fundamental differences between how the particles are interacting. In the gas state, the particles are very, very far apart, and they're really not interacting with each other at all. In the liquid state, the particles are very close. They are interacting with each other, but they're moving relative to each other. They're just sliding around. In the solid state, they are fixed in position. Now, does that mean they are not moving? No. Are you guys not moving? You're not moving relative to each other, but you're breathing, hopefully. And some of you are nodding, and some of you are doodling. That's okay. But you're wiggling, you're moving, you're shifting, but you're fixed in position relative to the students nearby. And that's what the particles in a solid are doing. So here are some slides that go over those details. Solid matter, the particles are close to each other in fixed locations. They're going to vibrate or oscillate, but they don't move around each other. Solids have fixed volume and rigid shape. You think of an ice cube. You pick up an ice cube and you put it in a big bowl. Does its shape change? Does its volume change? No. You take that ice cube from the big bowl and you put it in a little tiny cup. Does its shape or volume change? No. Solids retain their shape and they keep their volume. There are different kinds of solid matter. There's crystalline solids and amorphous. A is a prefix that means without. Amorphous means without shape. When a cartoon superhero morphs, what do? They change shape. Amorphous means without shape. In an amorphous solid, the particles are just kind of randomly jumbled together. They don't have a particular shape. In a crystalline solid, the particles are arranged in a definite pattern, and that pattern has long-ranging order. We see if we go up and down, there's a pattern. We go side to side, there's a pattern. Crystalline solids have repeating patterns. Amorphous solids do not. Liquids. In liquids, the atoms or molecules are still close to each other, but they're free to move around. So they're free to move. They have a fixed volume because the molecules or particles are still close together. So you take a cup of water in a 1 cup measuring cup and you pour it into a 9x13 baking pan. Does the shape of the water change? Yeah, it spreads out on the bottom of the pan. Does its volume change? No. If you pour it back into the measuring cup, you see, yeah, it's still 1 cup. So liquids have fixed volume, but they assume the shape of their container because the particles can move around. They're not fixed. In the gas state, the atoms or molecules are separated by large distances. They're free to move relative to each other. They're very, very far apart. Because the particles are not actually in contact with one another, the gases are compressible. So here we see an illustration. Here's a gas, and it's in this cylinder, and if we push down on the piston, we can push these particles closer together because there's empty space between them. If we try to do the same thing with a solid, these particles are already touching each other. If we push down on it, it can't get any smaller. Solids are not compressible. Liquids are not compressible, but gases are compressible. Gases always assume the shape and the volume of their container. So they assume the shape and volume of their container. Yes?
So since they're compressible, but they're only to a point.
Only
right?
to a point.
So once they're touching, though.
If you take a gas and you compress it far enough, it will condense into a liquid. Yeah. Any other questions? So here's table 3.1 from your textbook. Just gives you kind of a summary of the properties of these different states. So the 3 states, what's happening with the particles, their motion, how they're spaced, shape, volume, and compressibility. And so there will probably be at least one test question that, which state of matter retains its, has a fixed volume, but a variable shape. Well, that would be a liquid.